This is the tutorial for Chapter 1, Section 4, titled Properties of Real Numbers. So we're going to be looking at some different properties, not all of them, but some of them, in the real number system. And the first one we're going to take a look at is the commutative properties. So the commutative property right here is an important one. It deals with addition and multiplication. Basically says if you take the order of the numbers and switch them around, as long as you're adding or multiplying, you'll end up getting the same exact value. And then we'll look at the associative property as well, and that basically says that if you take the groups of numbers that are being added, so if I group A and B here, and then add C, it would give me the same thing as if I regrouped it. So associative property is like an association. It's the grouping property. And when we're looking at the commutative property, commute means to move, so it's the moving property. So when we move a term, it's the commutative property. When we group different terms, it's the associative property. We also have some others. We have the identity property of addition and multiplication. So that's when we add 0 to a number, we get the same number. Multiply 1 by a number, we get the same number. We use this property, the identity of addition, all the time whenever we try to solve an equation. So if I had 3x plus 3 equals 9, I use the identity property of addition to cancel out this 3 on the left-hand side. And so you see right here, these will make 0. And actually that's the inverse, but it has to deal with the identity property. And so if I add 0 to a number, it always makes that number as the identity property. Here, actually, this would be the inverse. So looking at the multiplication property, this one is used whenever we are changing fractions to equivalent fractions. So for instance, if I want to change 2/3 to an equivalent fraction, I might multiply it by 2 over 2. You see, this will change it to an equivalent fraction because it'll give me the same exact value, 4/6. Property of 0 just says whenever you multiply a number by 0, you get 0. And when we multiply by -1, it just means that it will switch signs. So we use those properties when solving equations or adding fractions, and many times when we'll end up dealing with different types of problems. So let's take a look at what we'll end up seeing today. Here it says to name the properties that are occurring. So let's take a look at the first one. So I see that 12 plus 917 is the same thing as 917 plus 12. So what they did is they moved 12. They switched it to the other side of the 917. So that's the commutative property. It's a commutative property of addition. And looking at number 2, whenever you multiply a number by 0 and you get 0, that is, if we go back here and look real quick, you can see that whenever we multiply a number by 0, we get that 0 property of multiplication. So 0 property of multiplication. Here we have two numbers being multiplied, and then they switched orders. They moved the 35 to the other side of x. So we have the commutative property again, but it's of multiplication. Here we have 3 times -1 times p, and then over here it's just -p. So if you go back and look right here towards the bottom, it said when we multiply a number by -1, it switches signs, and that's what we end up seeing on this problem here. So when we multiply -1 by a number, the number switches signs. So that's the, when we look at that, the multiplication property of -1. So we'll say multiplication property of -1. So on this next one, we have a number being added to 0 equals that same number. So again, looking back here, we can see that we are adding a number to 0, and we get that same number. So it's the identity property of addition. So identity of addition. And looking at this next one, here we're multiplying a number, 53 7/10 by 1, and we get that same exact value. So it's another identity property this time. And if we look at the property right here, multiplying a number by 1 gives us that same number. So that is the identity property of multiplication. Let's take a look at our next type of problem that we'll have. And here it says, in problem number 3, and that was above, You just don't see it here. Reasoning and properties were used to show that two expressions are equivalent. This example is deductive reasoning. So deductive reasoning is the process of reasoning logically from a given facts to a conclusion. So when we have given facts, we work our way to a conclusion. That's deductive reasoning. Where inductive reasoning is when we kind of experiment to be able to figure it out. So we're not sure about a result or reasoning or conclusion, and we're not sure about some given facts, that is, and we come up with a conclusion. That's the difference between the two. So oftentimes it says to show that a statement is not true, we find an example of which one that it makes it not true. And showing a statement that is false is called a counterexample. That's what we're going to try finding here. You only find one counterexample to prove that a statement is false. So let's take a look at this one here. It says, for all real numbers are just, remember, those rational numbers, and we had irrational numbers. And so it's any number that we deal with in this class is a real number. And so here we have a minus b equals negative b plus a. Well, this one actually ends up working because you see how they commuted this negative b just on the other side of a. So it's the same exact thing. So whenever you move a term to the other side of the variable or of the other term, as long as the sign goes with it, it's going to work. So this is actually the commutative property of addition that was used. And so that's going to be a true statement. Look at this next one. Here we have p minus q minus r. And here we have p minus r plus q. Well, the r's have the same sign, but the q got moved, but it doesn't have the same sign anymore. Notice here it's a negative sign, here it's a positive sign, so this is not going to work. So let's go ahead and substitute some numbers in. Let's say that p is 1, q is 2, r is 3. It doesn't matter which numbers I pick, and I can prove that it's false. And so we have 1 minus 2, and we had a minus 3. And then on the other side, we're going to have a 1 minus 3 plus 2. Let's see if we get the same answer. So when I subtract here, I get negative 1 minus 3 makes negative 4. On the other side, I get negative 2 plus 2 equals 0. Since these two numbers do not equal, that means this is false. And so that's a counterexample that we just came up with. So on this one it says, for all real numbers, it says x plus y plus z equals z plus x plus y. So basically they have the same exact thing. On this one here, they have what they did is they just used the commutative property again. They took the plus z, and they just moved it to the other side of the parentheses there. So this is the commutative property of addition. So this one is going to end up being true as well. So those are the types of problems that you're going to see on today's assignment. Good luck.